Every single element of our modern infrastructure rests on a single bedrock physical requirement: commercial-grade stainless steel. This alloy is a strict physical prerequisite for the high-pressure energy pipelines that move global power resources across continents. It is required to manufacture the heavy agricultural equipment necessary to plant, harvest, and sustain the global food supply. And it forms the material basis of the aerospace and defense manufacturing base. To manufacture this specific grade of steel, metallurgists must use chromium. There is zero known commercial substitute. All global infrastructure, our food security, and military capabilities are all entirely beholden to the continuous supply of this single element. Yet, the entire global economy's access to this material is dependent on a single geographic location. The world's largest, most commercially viable resources of chromite, the absolute sole source ore for chromium extraction, are trapped within the geological layers of the Bushveld complex in South Africa. This map visualizes the scale of the bottleneck. South Africa sits directly on top of approximately 72% of the world's known chromium reserves. Furthermore, that exact same location holds roughly 91% of the total global reserves of platinum group metals. These geological reserves translate directly into a tight grip on international trade. South Africa physically accounts for 76.1% of all global raw chromium ore exports. With neighboring Zimbabwe aggressively tightening restrictions on its own raw chrome ore exports, alternative sources are shrinking rapidly. The market is completely cornered. The global manufacturing sector is forced to rely almost entirely on South African export infrastructure. This extreme reliance exposes a structural flaw in the supply chain. There is no processed buffer. Processing raw chromite ore into usable material requires massive, energy-intensive smelting infrastructure. Over recent years, South Africa has experienced a 900% increase in electricity costs. Because of this extreme, unprecedented cost pressure on the local power grid, South Africa's domestic ferrochrome smelting industry has effectively collapsed. This chart tracks that structural devastation, showing the operational capacity plummeting from 66 active smelters down to as few as 11. Because the local grid can no longer afford to process the ore domestically, extraction companies are forced to export the raw rock directly out of the ground. Without domestic facilities holding reserves of processed ferrochrome, the global economy now operates on a hyper-fragile just-in-time system, dependent entirely on non-stop extraction. Acquiring that raw rock requires highly sophisticated, modern deep-shaft mining operations. This diagram illustrates the core challenge. Mine shafts extend thousands of feet beneath the water table. To stay dry, they require constant electrical power running massive groundwater pumps around the clock. A power grid failure, or targeted attack, immediately severs power to those pumps. Without active pumping, the deep mine shafts will rapidly and permanently flood. The raw chromite ore becomes trapped beneath the water table, rendering it physically unextractable. Political authority over the surface is irrelevant. A localized power disruption instantly triggers a severe, prolonged depression in global heavy industry. These factors shift the chromite supply chain from a commercial concern to a critical national security risk. Western governments officially designate chromium and platinum group metals as highly strategic foundational materials. These materials serve as foundational physical requirements explicitly needed to sustain national defense capabilities. This creates a precarious timeline if the Southern African chromite and platinum supply chains are severed by grid failure or regional destabilization. Because the collapse of the South African smelting industry has eliminated the global processed buffer, manufacturing now relies on the immediate inflow of raw ore. Without that flow, the math for heavy conventional warfare is clear. Production capacity depletes within 6 to 12 months. Global military supremacy is ultimately dependent on the continuous operation of localized water pumps in a single South African territory. Capital allocators and executives must reevaluate their risk models based on these physical realities rather than standard market assumptions. Standard supply chain risk assessments completely ignore this geological bottleneck and the reality of a zero-buffer system. The empirical data outlined in the Chromite to Capital Executive Promotional Sheet establishes the baseline for understanding the scale of this systemic threat. Navigating a physical monopoly of this scale requires specialized advisory and hyper-focused supply chain intelligence. This specific geopolitical vulnerability is the single most critical, yet overlooked, risk factor operating in modern heavy industry today. Institutional leaders must secure specialized advisory to quantify, mitigate, and navigate the chromite supply chain crisis before the buffer completely runs out.